Since ONOS is open source software, anyone is free to check out the code and build ONOS from scratch. However, ready-to-run ONOS distribution is also available as a compressed tar.gz file, which can be downloaded from the ONOS website. This screencast will demonstrate how to deploy ONOS on multiple machines, and it will show how easy it is to form a cluster from the individual ONOS instances using just the tar.gz file. I will be using iTerm to download, configure, and install ONOS on 3 machines at the same time. The machine's IP addresses will be the following: 10.128.11.1, 11.2, and 11.3. First, let's download the onos.tar.gz distribution file. To do that, we will use wget, but you can use curl or your favorite browser. For our demonstration, we will download the latest daily snapshot of ONOS as follows. Once the download has completed, we will untar the package. I will extract it directly under the home directory, but you can choose an alternate location if you wish. Once ONOS download has been extracted, we are ready to configure the environment to run ONOS. To do that, we will run the supplied onos-config tool and specify the IP prefix for the cluster network as follows. This step will configure ONOS to use the given network for intra-cluster communications. Having configured ONOS, we are now ready to start it. The recommended way to start it is to use some form of a Linux watchdog daemon, such as upstart, for example. ONOS comes with a configuration file which can be used to copy under the system directory on Ubuntu to register ONOS as an upstart service. In our demonstration, we will use ONOS directly using the supplied onos-service script. We will run it in a server mode and in the background as follows. We can monitor the startup progress by tailing the log file. Also, we can use the provided ONOS tool to connect to ONOS command console via SSH. Once there, typing the onos nodes command will reveal that each instance is in its own cluster, meaning that these instances are not aware of each other. To form a cluster from these individual instances is quite easy using the supplied ONOS form cluster tool. We simply need to specify the IP addresses of all the cluster nodes, and the tool will create a cluster configuration JSON object and then upload it to each instance using its REST API. To complete the operation, each instance will restart automatically, and when they all come back up, they will be part of the same ONOS cluster. We can verify this by connecting to the ONOS command console and typing onos nodes command again. This will reveal that each instance knows about the others. To prove this further, let's use the user interface pointed at the first ONOS instance to activate the ONOS OpenFlow providers. Checking via onos apps command, we can see that the providers were activated on all the cluster nodes. Finally, just for fun, let's switch the UI to the topology view, and then let's start a simple mininet topology whose switches are configured with only one of the instances as their controller, say the second one. We can see that the information about the discovered switches was quickly propagated through the cluster, as the GUI shows all the switches and the links between them. I hope that you find this screencast useful in deploying ONOS on your networks. Have a great day.